Good afternoon, everyone. Today we continue the exercise 7.6 from question 12 to question 24. In the previous class, we solved some question on integration by parts. Okay. So the first question is, we have to integrate the function x sec square x. So as in integration by parts, we have to choose the first function and second function by the elect rule. So apply the elect rule and think which function we have to take as u and which function we have to take as dv. So the answer is x 10x plus log cos x plus constant of integration. Let's go through the solution. To integrate the function x sec square x, we use the integration by parts formula. The formula is integration of u dv equal to u v minus integration of v du. So at first we have to choose u and dv. So we apply the elect rule, and according to elect rule, the algebraic function come first and then trigonometry. So we take x as u and sec square x dx as dv. So after that we have to find the value of du and v. To find du, we differentiate u with respect to x, and to find the value of v, we just integrate dv. So when we differentiate x with respect to x, we get 1. So du is equal to 1 dx. And when we integrate sec square x dx, we get v is equal to 10x. Because differentiation of 10x is sec square x and integration is inverse of differentiation. So when we integrate sec square x, we get 10x. So the value of du is 1 dx and the value of v is 10x. Now substitute this value into integration by parts formula. So we get I is equal to x 10x. 10x is the value of v minus integration of v, that is 10x, into du, that is 1 dx. Simplify it. So when we simplify, we get integral is equal to x 10x minus integration of 10x dx. So now we have to find the value of integration of 10x dx. We know the standard integral. When we integrate 10x dx, we get log sec x plus c, that is constant of integration, or minus log cos x plus c. We already do in previous exercise. So we get x 10x minus into minus log cos x plus c. So the final answer is integration of x sec square x is x 10x plus log cos x plus c. So the next question is, now we have to integrate the function x log x whole square. So just think which function we should have taken as u and dv. So the answer is x square by 2 log x whole square minus x square by 2 log x plus x square by 4 plus constant of integral. Solution part. Now we apply the integration by parts formula to integrate this function. There is two functions. First one is log x whole square and second one is x. In this question we needing to applying integration by parts multiple times because they're involving a term log x whole square. So the formula of integration by parts is integration of u dv is equal to u integration of dv, that is v, minus integration of v, that is integration of dv, into du, that is differentiation of function u. So let u is equal to log x whole square and dv is equal to x dx. By the Elite rule, as logarithmic function come first, then algebraic. So at first we differentiate u with respect to x to get the value of du. So we have to differentiate log x whole square. To differentiate log x whole square, we have to apply chain rule of differentiation. So what is the chain rule? If we have to differentiate fx power n, then the differentiation is n fx the power n minus 1 into differentiation of fx. So the differentiation of log x square is, as here fx is equal to log x, the value of n is 2 and differentiation of fx, that is differentiation of log x, is 1 by x. Just substitute into chain rule, we get du is equal to 2, that is n, into log x, 2 minus 1, that is 1, into differentiation of fx, that is 1 by x, into dx. So the value of du is 2 log x 1 by x dx. Now we integrate dv to get the value of v. So the integration of x dx is x square by 2. Now substitute the value into integration by parts formula. So I is equal to x log x whole square dx is equal to uv minus integration of v du. So the value of u is log x whole square, the value of v is x square by 2, and the value of du is 2 log x into 1 by x dx. So when we simplify, we get x square by 2 log x whole square minus integration of x square by 2 into 2 log x by x dx. So in second term, x got cancel out and also 2, so we get x into log x dx. Now we have to integrate x log x. So we have to apply integration by parts formula on the term integration of x log x dx. Let's consider it as j is equal to integration of x log x dx. We apply the Elite rule to choose u and dv. So u dash is equal to log x and dv dash is equal to x dx by Elite rule. So when we differentiate u dash with respect to x to get the value of du dash, so differentiation of log x is 1 by x. So du dash is equal to 1 by x dx. And to get the value of v dash, we just integrate dv dash with respect to x. So different integration of x is x square by 2. Substitute this into the integration by parts formula. We get j is equal to log x, that is a value of u dash, then v dash x square by 2 minus integration of x square by 2 and du dash is 1 by x dx. Simplify the expression. We get x square by 2 log x minus integration of x square by 2x dx. X got cancel out from numerator and denominator. So we get the first term minus integration of x by 2 log x. Integrate the remaining term, integration of x by 2 to x by 2 dx. So 1 by 2 is come out from the integration sign and the integration of x is, we have to apply the formula integration of xn, that is xn plus 1 by n plus 1. So integration of x is x square by 2. When we simplify, we get I is equal to x square by 2 log x. Just substitute the value of the integral j. We get x square by 2 log x minus x square by 4 plus c. Simplify it. So the final answer is x square by 2 log x whole square minus x square by 2 log x plus x square by 4 plus c. So next question is integrate the function x square plus 1 into log x. So apply elect rule, find the value of which function we should have taken as u and dv, and try to solve. So the answer is x cube by 3 plus x log x minus x cube by 9 minus x plus c. To integrate the function x square plus 1 log x, we first expand the integrand and split into two similar integrals. So when we expand, we get integration of x square log x plus log x dx. Integration got separated on summation, so we get integration of x square log x dx plus integration of log x dx. So now we have to integrate these two integrand. First one is x square log x and second one is log x. So let's consider first term as I1 and second term as I2. Then original solution it become I is equal to I1 plus I2. So we have to find the value of I1 and I2. So let's evaluate I1 and I2 by using integration by parts. So we will evaluate I1, that is x square log x dx. So we take u is equal to log x and dv is equal to x square dx by elect rule. Logarithmic come first, then algebraic. So log x as u and dv is equal to x square dx. To get the value of du, just differentiate it. So when we differentiate u with respect to x, we get du is equal to 1 by x dx. And to find the value of v, we integrate x square dx. So v is equal to x cube by 3. When we substitute into integration by parts formula, so I1 is equal to log x into x cube by 3 minus integration of x cube by 3 into 1 by x dx. Simplify it, we get first term, that is x cube by 3 into log x minus integration of x square by 3 into dx. Now apply the standard formula of integration of xn, that is xn plus 1 by n plus 1. So integration of x square become x to the power n plus 1, that is 3, by n plus 1, that is 3. So the value of I1 is x cube by 3 into log x minus x cube by 9 plus c1. Now we will evaluate I2, that is we have to integrate integration of log x. We take log x as first function, that is u, and 1 as second function, that is dv. So when we differentiate u to find du, we get du is equal to 1 by x dx. And when we integrate dv to get the value of v, we get integration of 1 dx, that is v is equal to x. Substitute these values into formula, we get I2 is equal to log x into x minus x into 1 by x dx. So I2 is equal to x log x minus integration of 1 dx, and integration of 1 is x. Then we add constant of integration. So when we combine I1 and I2, we get the value of I, original integral. So I is equal to x cube by 3 into log x minus x cube by 9 plus c1 plus x log x minus x plus c2. Combining the terms and constant, so c1 plus c2 become another constant. So I is equal to x cube by 3 into log x plus x log x minus x cube by 9 minus x plus c1 plus c2. Factor out the term of log x and take c as a c1 plus c2 new arbitrary constant. Therefore, the value of integral is x cube by 3 plus x into log x minus x cube by 9 minus x plus constant of integration. So the next question is, we have to integrate the function ex into sin x plus cos x. At first, try by your own. Yes. 14. 14.
14. जब next 30 seconds का break लोगे ना.
So the answer is ex sin x plus c. When we have to integrate ex sin x plus cos x, we recognize it as a special form, and we can directly integrate it by using that special form. So what is the special form? Whenever we have to integrate the integrand like ex into fx plus f dash x dx, the value of integration is ex into fx plus c. So we just need to find which function we have to taken as fx, and there must be f dash x, so that we can write it as ex into fx plus c. So in this question, the given integrand is ex sin x plus cos x, and we can see that cos x is a differentiation of sin x. When we differentiate sin x, we get cos x. So the value of fx is sin x. When we differentiate it, we get f dash x, that is cos x. So it matches the special form, that is ax into fx plus f dash x, where fx is sin x and f dash x is cos x. Therefore, applying the formula, the integral is ex into fx plus c. So the value of integral is ex into sin x plus c. Also, we can solve this problem by the by parts method. At first, we have to separate it so that we get integration of ex sin x dx plus ex cos x dx. Now we have to apply the integration by parts formula in both terms. So when we integrate ex sin x, we have to check which function as we have to taken as u and which function as dv. So by Euler rule, u is equal to sin x and dv is equal to ex dx, as trigonometric function is come first, then exponential in Euler rule. So to find the value of du, we just differentiate function u with respect to x. So the value of du is cos x dx, and to get the value of v, we integrate dv, and integration of ex is again ex. So apply the by parts formula and simplify it. We get I is equal to ex sin x minus ex cos x dx plus the second term, that is ex cos x dx. the two integral terms cancel out. The second term and third term, first one is a minus with minus sign and then plus with plus sign. So the value of integral is ex sin x plus c. So we can solve this solution by both method. First, directly apply the special case and then using the by parts formula. Therefore, the final value of integral is ex sin x plus c. The next question is, we have to integrate the function x into ex by 1 plus x whole square. Just think, can we apply the special case or we have to solve by parts method? Yeah. So the answer is ex by 1 plus x plus c. Let's go to the solution part. Now we have to integrate the function x into ex by 1 plus x whole square. So now our aim is to express into the special form, that is ex into fx plus f dash x. So we have to find which so allow us to direct integration formula, that is integration of ex into fx plus f dash x dx is equal to ex into fx plus c. Let's manipulate the factor so that it can be distributed as fx plus f dash x. So we add and subtract 1 in the numerator. So x by 1 plus x whole square become 1 plus x minus 1 divided by 1 plus x whole square. So separate the terms. We get 1 plus x by 1 plus x whole square minus 1 by 1 plus x whole square. Cancel out 1 plus x into numerator and denominator in first term. We get 1 by 1 plus x minus 1 by 1 plus x whole square. So our original integral becomes integration of ex into 1 by 1 plus x minus 1 by 1 plus x whole square dx. Now we separate this as in first term and second term. Now we have to choose which function we should have taken as fx, and there must be differentiation part, that is f dash x. So when we differentiate 1 by 1 plus x, we need to identify fx and f dash x. So let fx is equal to 1 by 1 plus x. And now we have to find f dash x. So we differentiate fx with respect to x. So differentiation of, we know when we differentiate x to the power n, that's become n into x power n minus 1. So when we differentiate 1 plus x to the power minus 1, the differentiation value is minus 1 into 1 plus x power minus n minus 1, that is minus 2, and d by dx 1 plus x, that is chain rule. So the value of f dash x is minus 1 into 1 plus x power minus 2 into 1, that is differentiation of 1 plus x is 1. So So the value of f dash x is minus 1 by 1 plus x whole square. That is our second term. So we identify fx and f dash x. So we directly apply the special case to find the value of integral. So applying the formula, the value of integral is ex into fx, and the value of fx is 1 by 1 plus x plus c. The final answer is ex by 1 plus x plus c. Now, next question is integrate the function ex into 1 plus sin x by 1 plus cos x. So can we convert into a special case, or we should apply the by parts method? Just think and try to solve. Okay, everyone. Now let's solve question together. So the answer is ex 10x by 2, 10x by 2 plus c. To integrate the function ex into 1 plus sin x by 1 plus cos x, we need to manipulate the trigonometric expression 1 plus sin x by 1 plus cos x, so that to fit the form fx plus f dash x. Okay, we have to convert into a form of fx plus f dash x. We just use the knowledge of trigonometry so that we can directly apply the direct integration formula. So we know that sin x is equal to sin 2x is 2 sin x into cos x. We apply the half angle identities, that is sin x can be written as 2 sin x by 2 into cos x by 2, and 1 plus cos x is equal to 2 cos x square x by 2, and the 1 can be written as sin square x by 2 plus cos square x by 2. Now we use these identities to simplify the term. So 1 plus sin x, in place of 1 we substitute sin square x by 2 plus cos x square x by 2, and in place of sin x we substitute 2 sin x by 2 into cos x by 2, and 1 plus cos x is 2 cos square x by 2. Now the numerator is a perfect square of sin x by 2 plus cos x by 2 whole square. So the expression become sin x by 2 plus cos x by 2 whole square divided by 2 cos square x by 2. Now we separate the numerator by dividing each term by cos x by 2. So we get sin x by 2 by cos x by 2 plus cos x by 2 by cos x by 2 whole square. So 1 by 2 into sin by cos is 10. So it becomes 10x by 2 and cos cancel out. So we get plus 1 whole square. Now we expand 10x plus 1, 10x by 2 plus 1 as a plus b whole square, that is a square plus b square plus 2ab. So it becomes 10 square x by 2 plus 1 square plus 2 into 10x by 2 into 1. And we know 1 plus 10 square theta is equal to sec square theta. So 10 square x by 2 plus 1 square, that is 1, can be written as sec square x by 2 plus 2 into 10 x by 2. Just distribute 1 by 2. So the original integral become ex into the 10x by 2 plus 1 by 2 sec square x by 2. We separate into a two terms. Now we have to find fx and f dash x. Identify which function is fx and which function is f dash x. And we know that differentiation of 10x is sec square x. So the first term is fx and the second one is f dash x. Just check. Fx is equal to 10x by 2. When we differentiate with respect to x, the differentiation of 10x is 10u is sec square u into du by dx. So differentiation of 10x by 2 is sec square x by 2 into differentiation of x by 2, that is 1 by 2. So we get 1 by 2 into sec square x by 2. So it is indeed in the form of integral of ex into fx plus f dash x dx. Therefore, by applying the formula, the integral is ex into 10x by 2 plus c. So question number 19 is, we have to integrate the function ex into 1 by x minus 1 by x square. Just choose, identify which function is fx and which one is f dash x and apply the special case. Okay, so the answer is ex by x plus c. In such kind of question, we have to choose fx and f dash x if it is given in summation of two terms. But if it is not in summation of two terms, then we have to apply algebraic manipulation, trigonometric manipulation, so that it converted into a summation of two terms, and then we have to choose fx and f dash x. And if we can't apply the special case, then we just need to apply the by parts method. Okay, so the solution, we can see it is in special form, so we directly apply the formula. So the integration of ex into fx plus f dash x dx is ex into fx plus c. So identify fx and f dash x. So what do you think? We can, when we differentiate 1 by x, we get minus 1 by x square. So let's take fx as 1 by x and differentiate with respect to x to get f dash x. So fx is equal to x minus 1. Apply the general formula of power n, that is differentiation of xn is n into x into n minus 1. So differentiation of x minus 1 is minus 1, that is n, into x to the power minus n minus 1, that is minus 2. So it becomes minus 1 by x square. So the value of fx is 1 by x and f dash x is minus 1 by x square. Applying the formula, the integral is ex into fx, that is 1 by x, plus c. The final answer is ex plus ex by x plus c. Let's go to the next question. Now we have to integrate the function x minus 3 into ex by x minus 1 the power 3. Now it is not given in a separate terms of 2. So we have to apply either algebraic manipulation or trigonometric manipulation so that it converted into a special case. Or we can directly solve by integration by parts. So the answer is ex by x minus 1 into whole square plus c. Let's go to the solution part. Now, what is our aim? Aim is to express this in the form of ex into fx plus f dash x, so that we can apply the direct integration formula. That is, integration of ex into fx plus f dash x is ex fx plus c. Now we manipulate the fraction. Now in the denominator there is x minus 1 whole cube. So that there is an idea that we should express the numerator in the term of x minus 1. So we can write x minus 3 as x minus 1 minus 2. Separate the terms. We get x minus 1 by x minus 1 whole cube minus 2 by x minus 1 whole cube. So when we divide, cancel out x minus 1 numerator and denominator in first term. So we get 1 by x minus 1 whole square minus 2 by x minus 1 whole cube. Now we have to identify fx and f dash x. So our original integral become ex into 1 by x minus 1 whole square minus 2 by x minus 1 whole cube into dx. So to identify fx and f dash x, we apply the property of differentiation. So when we differentiate 1 by x minus 1 whole square with respect to x, we get x minus 1 whole square minus 2. Apply the property of differentiation of xn. So we get minus 2 into x minus 1 the power minus 3 by the chain rule. Then we differentiate x minus 1. So we get minus 2 into x minus 1 the power minus 3 into 1. So the finally we get f dash x is equal to minus 2 by x minus 1 whole cube. That is the second term of our integrand. we can see that our integral is indeed in the form of ex into fx plus f dash x dx. Now apply the formula. So the value of integral is ex into fx, that is ex into 1 by x minus 1 whole square plus c. Therefore, final answer is ex by x minus 1 whole square plus c. Question number 21 is integrate the function e the power 2x into sin x. So choose u and dv and try to solve. Okay, so the answer is e the power 2x by 5 into 2 sin x minus cos x plus c. Let's solve step by step. We apply the integration by parts. This type of integral, exponential multiplied by trigonometric, typically require two application of integration by parts, leading to an equation that can be solved for the integral itself. So here we have to apply integration by parts repeatedly so that we get an equation, and that equation is used to find the value of integral. So integration by parts formula is integration of u dv is equal to uv minus integration of v du. So by Elliott rule, choose u and dv. So u is equal to sin x and dv is equal to e to x. As trigonometric function come first, then exponential. Now we have to find the value of du. So just differentiate u with respect to x. So differentiation of sin x is cos x. So du is equal to cos x dx. And to find the value of v, integrate dv. So integration of e to x dx is v is equal to e to x by 2. Just substitute into by parts formula. We get sin x into e the power 2x by 2 minus integration of e to x by 2 into cos x dx. So e to x sin x by 2 minus constant terms come out the sign of integration, and then integration of e to x cos x dx. Now we have to evaluate the new integral e to x cos x. We take it as j is equal to integration of e to x cos x. Again apply the integration by parts formula. And remember, we take integration of e to x sin x as I, the original integral. So when we apply integration by part formula, on j, we have to choose trigonometric function as u and exponential function as v. When we differentiate u, the differentiation of cos x is minus sin x. So du is equal to minus sin x dx. And when we integrate dv to get the value v, integration of e to x dx is equal to v is equal to e to x by 2. Substitute into integration by parts formula to find the value of j, that is uv minus integration of v du. So cos x into e to x by 2 minus integration of e to x by 2 into minus sin x dx. Simplify it, we get e to x cos x by 2 plus 1 by 2 integration of e to x sin x dx. Now, the last part In the last part, when we integrate the value to find the value of j, we get e 2x cos x by 2 plus 1 by 2 integration of e 2x sin x, and that is I. So just put in the place of integration of e 2x sin x. So substitute back the value of j into the equation 1 to solve for I. So I is equal to e 2x sin x by 2 minus 1 by 2 j, that is e 2x cos x by 2 plus 1 by 2 I. Now we get an equation. Distribute minus 1 by 2. We get e 2x sin x by 2 minus e 2x cos x by 4 minus 1 by 4 I. Solve this equation and collect the terms involving I on one side. On the left hand side, we get I plus 1 by 4 I is equal to e 2x sin x by 2 minus e 2x cos x by 4. Combining the I terms. So 1 plus 1 by 4 into I is equal to 2 into e 2x sin x minus e 2x cos x by 4. So we get 5 by 4 into I is equal to e 2x 2 sin x minus cos x by 4. Simplify the expression. Multiply both sides by 4 by 5. So I is equal to 4 by 5 into e 2x into 2 sin x minus cos x by 4. 4 cancel out. So we get e 2x into 2 sin x minus cos x by 5 plus c. And remember, don't forget to add the constant of integration. It finally stays. Therefore, the integral of e 2x sin x is e 2x by 5 into 2 sin x minus cos x plus c. Let's go to the question number 22. Now we have to integrate the function sin inverse x into 2x by 1 plus x square. Just think how we can solve. And try to solve. Okay, so the answer is 2x tan inverse x minus log into 1 plus x square plus c. Let's go to the solution part. To integrate the function sin inverse x into 2x by 1 plus x square, we first simplify the inverse trigonometric expression using trigonometric substitution. So at first we substitute x equal to tan theta. Then differentiate with respect to theta. to find dx. So the value of dx is, differentiation of tan theta is sec square theta. So dx is equal to sec square theta into d theta. We just use the trigonometric substitution so that we can simplify the inverse trigonometry function, because we don't know how to integrate inverse trigonometry. Now substitute x equal to tan theta into the argument of sine inverse, that is in place of x put tan theta. So sine inverse into 2 tan theta by 1 plus tan square theta. So we know the trigonometric identity is that 2 tan theta by 1 plus tan square theta is sine 2 theta. So the expression become sine inverse into sine 2 theta is equal to, for theta belongs to minus pi by 2 to pi by 2. So 2 theta belongs to minus pi 2 pi. Apply the formula of inverse trigonometry, apply the identity of inverse trigonometric function, that is sine inverse. So when x belongs to minus 1 to 1, 2 theta belongs to minus pi by 2 to pi by 2. So theta belongs to, just multiply by 1 by 2, minus pi by 4 to pi by 4, which means x belongs to minus 1 to 1. In general, we can write sine inverse sine y is equal to y when y belongs to minus pi by 2 to pi by 2. For this problem, x in such that 2 theta falls within the range, so just apply sine inverse into sine 2 theta, it become 2 theta. So now substitute 2 theta for the integrand and sec square theta d theta for dx. The integral become integration of 2 theta into sec square theta d theta, that is 2 into integration of theta sec square theta into d theta. Now we apply integration by parts for integration of theta sec square theta d theta. We choose theta as u and sec square theta as dv. Differentiate u with respect to theta to get the value of du. So du is equal to 1 d theta, and the value, to get the value of v, just integrate sec square theta with respect to theta, we get v is equal to tan theta. Now substitute this into the integration by parts formula. We get 2 is into theta into tan theta minus integration of tan theta 1 d theta. So now we have to find the value of the integrand, integration tan theta. We know that integration of tan theta is minus log cos theta plus c dash. So the expression become 2 into theta tan theta minus into minus log cos theta plus c. Simplify it, we get 2 into theta tan theta plus log cos theta plus c. Substitute back the value of in terms of x. So in place of theta, as x is equal to tan theta, by applying the inverse trigonometry function, theta is equal to tan inverse x. So in place of theta, just substitute tan inverse x. And by the right triangle, tan theta is equal to x by 1, that is p by b. So the hypotenuse, apply the Pythagoras formula, we get h is equal to root under 1 plus x square. So the value of cos theta is b by h, the value of b is 1 and h is root under 1 plus x square. So now we have the value of theta and cos theta. Just substitute, so we get log cos theta is equal to log into 1 by root under 1 plus x square is equal to log into 1 plus log 1 plus x square power minus 1 by 2. Substitute this back into the integral. We get I is equal to 2x tan inverse x plus 2 into minus 1 by 2 log 1 plus x square plus c. as 1 plus x square is always greater than 0, so we can remove the absolute value sign. Therefore, the value of the integral is 2x tan inverse x minus log 1 plus x square plus c. Okay, that's all for today. Thank you. See you in the next session.